Hello, and welcome to the last leg of the 2024 Commodore 64 Repairathon on yet another retro channel. We have on the bench the last of the 10 machines, number 10. This machine is in roughly the same shape as the rest. We got a little bit of gunk stuck to the case here. It's dirty. The keyboard actually feels pretty normal. Not feeling any stuck keys or anything like that. Our badging is good. If we look at the back, we have some Scotch tape. I already took some Scotch tape off the front with the help of my hot air station. And this is coming loose pretty easily. Stuff on the front was stuck a little harder. There. Got rid of that. Our ports, our RF port looks a little dirty, but, and of course our card edge connectors will need cleaning, and our cassette port, our cartridge port rather. Looking at the side, these ports look like they're in pretty good shape. And if we flip to the bottom, we don't have a note this time. We do have all 4 feet. We have none of the 3 screws. So today, instead of going directly for the power on to see what's going on, for a couple of reasons. One, because there's no note to tell me what to expect, and also because some of the feedback that you guys have been giving me, I'm going to try to incorporate. And one of the things that was mentioned, and I do this sometimes, but I haven't been during this Repairathon, is I should open it up, give it an inspection, make sure everything looks okay before we power on. Also, make some checks before powering on. So let's go ahead and get this thing opened up, which is easy because we do not have the screws. So I can go ahead and lift the shell and take a look at what we've got going here. First, I'm looking at the keyboard, and it looks like there is an issue here. I don't know if, I'm not sure how well you'll be able to see this, but the shift lock key, which is normally connected through these 2 holes, has been snipped. So whoever worked on it before didn't know they could simply desolder these connections here, and they snipped the wires, and I'll have to repair that. So that's for some future work. We're also, and we've got all 4 screws for the keyboard. The keyboard, if you didn't notice, was already disconnected from the board, and the LED is also not connected. So let's set the top of the case aside and give this machine a visual inspection. Now, this is a 250407 Rev A board. So let me grab a pokey thing and get our VIC case off here. VIC RF shield opened up. Apologize, OBS crashed there. I don't know if some of the video might be missing, but I was about ready to remove the RF can lid over the VIC-II. Always a violent thing to do. This has apparently been worked on before, but I'm seeing thermal paste here, but not on the VIC-II itself. So it's actually still the thermal paste has actually still got a little bit of moisture to it, but it didn't adhere to the VIC-II. Now, here's where we run into some issues. We have an R56A VIC-II from the 11th week of 83. These are known to have less than outstanding video output, so I may swap this, even if it's working, I may swap it with an R8 or R9. We have, oh dear. Well, I'm going to say it's a very good thing that I didn't power this up. We have a PLA in the SID socket and the SID in the PLA socket. If this has been powered like this, it's very likely that the PLA has been fried by the 12 volts that is normally fed to the PLA in these early revision longboards. This it's rather unfortunate because this was an 82S100 PLA, meaning that it was probably at some point a very reliable PLA. Now it may still work if this person never powered this up with the PLA in the wrong slot or wrong socket. It may still be good, but he'd obviously been working on too many 425 boards and put the PLA in the wrong slot or wrong socket. So we're going to pull that out, and we'll have to give that a test. For sake of the original or the first power on and more on this board, I'm going to go ahead and pull the 6581 29th week of 84 SID chip and hope that that's still good. And I'm also going to pull the VIC chip for the first power on, because right now we don't know anything about these two voltage regulators, and they could give the wrong voltages out and damage these two rather valuable chips. So we're going to pull them out. Both the VIC-II and the SID run off that 12 volts that's coming from this regulator right here. Now, looking around the board again visually, we have a ceramic 6510, oddly appears to be the 10th week of 1986, which is late for a ceramic CPU, but there you go. Character ROM, kernel, and basic look to be the right ones. We've got 13th week of 83, 15th week of 83, and 27th week of 84, so this may be a replacement basic ROM. We have 6526 R4 and 6526. These are from the 5th week of 83 and the 20th week of 84. Let's see, what else have we got here? We have all of these are socketed, so at some point they've been desoldered and socketed if they weren't socketed from the factory. We have socketed RAM, and again, if these weren't socketed from the factory, at least one of these sockets has been replaced. I've never seen Commodore use one of these white sockets before. As for our RAM itself, we have Mitsubishi, TI, I'm not familiar with that symbol, MOSTEC, TI, and another one with the symbol I'm not familiar with. So we don't have any MT RAM to worry about. Our logic chips, our 257s, are both TI. TI on the LSO8, National Semiconductor on the 2114 color RAM. The 4066s, one of them, again, I'm not really familiar with that maker's mark. This is a Motorola. TI, I believe that's Ferranti, and that's TI. So I'm not seeing any MOS branded logic that we have to worry about. We may be in pretty good shape with this machine. So check our fuse for continuity. Can do that without any power. Our fuse is good. Oof. 5-volt regulator looks a bit mangled. Bring this up here for you. I don't know how well you'll be able to see that. I'm not focusing. Well, I'd have the autofocus turned off on the camera. It looks like one of those pins has been, at least of those pins has been clipped and resoldered together. So we may replace the 5-volt regulator just on principle. The 12-volt regulator looks fine. The bottom shield has already been desoldered and is out of the board. And we have none of the interior screws, so we go to put this back together. I'll have to get new screws. As usual, I do not keep these, so those are going in the trash. And we'll go ahead and take the bottom of the case, which is relatively clean inside, and looks like most of these screw holes. Some of them look a little bit stressed, but relatively okay. So we are, as I said, working with a 407. I'm going to check, forgive me if I get this wrong, but I believe what I need to check on these regulators without powering them on is to look for, it should be open line between the input and the base, and open line between the input and the output. And then, how did that go? It should have a measurable resistance between the output and the base. Is that how it went? 15K. Okay, I think that one's probably good. And then on the 5-volt regulator, fluctuating. Sometimes it's open line or over limit or whatever OL stands for on a meter, and sometimes it's got several hundred K ohms, and I don't think that's right. Yeah, I don't like this regulator for two reasons. One, I don't think the readings are looking right, and I've got that leg that's been soldered back together. So I'm going to go ahead and swap this guy. While I'm waiting for my desoldering station to heat up, I'm going to grab the ZIF board, and we are going to give that PLA a test and see if it's been killed. So first we will make sure the ZIF board is working, and I do have my power supply turned on. And the ZIF board is working. So let's pop out our known good PLA and grab the PLA from the board that we're testing. And when you look at that, the PLA is good. So that's good news. We haven't ruined an 82S100 PLA. Or I wouldn't have ruined it. Now, someone else mentioned in the comments that they thought it was illogical of me to go to testing signals and things without testing chips in the ZIF board. And there's a reason that I do it this way. Or there are several reasons I do it this way. One, if I just pull the chips and test them in the ZIF board and they come up bad, I haven't actually seen the problem. I have just skipped all those testing steps. I only did it with the PLA here because we already had it out, and we had reason to suspect that there might have been damage caused by the voltage with it being in the wrong socket. So another reason is not everybody has a good working Commodore 64, particularly one with socketed chips, especially ZIF sockets. But any sockets would do in a machine that is working to test parts on a machine you're working on. But not everybody has that luxury. So I try to do my diagnostics in a way that you could do. Now, not everybody has an oscilloscope, but as I've shown before, there are inexpensive oscilloscope options out there that you can buy $25–$30 from AliExpress, for instance, that are perfectly adequate to testing an old 8-bit machine like the Commodore 64. So I do my diagnostics in a way that maybe most of the folks out there can do. I don't want to just rely entirely on the ZIF board or a working C64 to test chips, because not everybody has that resource. Not everybody has an oscilloscope either, but like I said, you can get one for a relatively inexpensive price, and worst come to worst, you can use a logic probe, which are also relatively inexpensive. I've seen some of those for around $15 on AliExpress. Now, I don't recommend personally the logic probe. I don't like the logic probe because the logic probe will tell you if you're at 5 volts, if you're at 0 volts, if your signal is pulsing, but it won't, for instance, let you do things like measure clock frequencies. All you do is you get the little sound, and that doesn't tell you if your clock is at, for instance, 1.02 megahertz or 3.8, whatever it is for the color clock or whatever. So I think logic probes are of limited use. If you're going to spend $15–$20 on a logic probe, you may as well go ahead and spend $25–$30 on a small handheld oscilloscope that'll do the job for you. At any rate, our PLA is working. One more thing we can do while we have this up here and while we have the other chip out. Again, I may swap this out anyway because it is an R56A, which does not have the best picture output, but we'll see if our VIC-II is working while we've got this up here. And it actually is, so our VIC-II is good on this machine. And I suppose while we're up here, we may as well try out the SID. So let's see if we happen to have a working SID. Easy flash. I need a controller. I was told by someone in the comments when I mentioned that I blew a CIA by putting in the test harness dongle for the control ports. Someone did recommend that not only do I wear the wrist strap, but I also should, or anyone should, actually disconnect the power supply from the machine, because what this does is give any static charge a path to ground. So now when I plug in controllers or plug in the control port dongle, I go ahead and disconnect the power supply to make it just a little bit more safe. So, well, the machine still works. That's good news. So let's go ahead and see if the SID is working. I'd be surprised if it was. Well, I'll be a monkey's uncle. Kind of appropriate, right? Monkey. The SID is working. What do you know? So we have 3 good chips already. Now, the SID could still have problems with the part of itself that operates the control port, but at least the sound is good. I didn't hear anything wrong with that at all. So, as I said, we're going to go ahead and desolder the 5-volt regulator. make sure we didn't bridge anything. Nope, we're good. So we now have a new 7805 regulator in here. We have a good fuse, and we have the VIC and SID, VIC and SID out. So let's give this power and see if we get in the right voltages. We're not going to get any video, so I'm not going to hook that up right now. Okay. All right. We have 5 volts on the 5-volt regulator, 11.8, 11.79 on the 12-volt regulator. So those voltages are good. Let's see what we're getting on our 5-volt rail. All the way over at the user port. 4.75. That's close to what we want, not quite all the way there. I'm going to check resistance on the switch. Well, I'm not showing any resistance there. 0.1 of an ohm at most. And on the 9-volt side, 0.1 of an ohm. So that switch looks pretty good. We could have a dirty power socket, so we'll give that a shot of deoxit. And insert and remove the plug a few times to see if we can clean off any oxidation that may be in there. And I suppose just to be on the safe side, we could spray a little deoxit into the switch and see if we can improve things any in there. And give that a little exercise. Let's see if we've improved anything by doing that. What are we getting on the user port now? 4.8, so that's better than it was. I think we improved it a bit. That's enough for it to run. It's not perfect, but it's enough for it to run. So we have a good 5 volts from the external power supply, good plus 5 and plus 12 from the regulators, so it should be safe now to reinsert the VIC-II. And the PLA. We're just going to leave the SID out for now. We do know it's working, but we don't want to take a chance on blowing it out with something weird. So now that we've got our video chip back in, we can go ahead and try for some output and see what we get. Well, will you look at that? We've got a working machine. We'll have to run it through some diagnostics, but this one may have been the easiest of the bunch. I think probably the biggest problem was that he had the SID and the PLA swapped. And there was possibly a problem with that voltage regulator. But we'll take a break here and I'll come back and do some diagnostics. Okay, so I have returned the SID to the board. I have installed the test harness and the diagnostic cartridge. I also took the precaution of cleaning the user port and cassette port with the fiberglass pen and a little IPA. And I think we're ready to give this a shot. So here we go. Looking good so far. Timers are working. Good. Well, that was a flying success. So, one last thing to do, and it should be fine. But we will switch over and do a little Donkey Kong arcade.
And that'll do it for machine number 10. So we've reached the official finish line for the 2024 Repairathon. It was nice to have an easy repair to go out on. All we had to do was replace the 5-volt regulator and swap the SID and the PLA back into the correct sockets. But hold on. If I end the episode now, it'll be less than a half hour long. How about a little bonus for sticking with me through this? Let's revisit machine number 2. If you remember, that's the machine that appeared to have been used as a parts donor and had most of its big MOS chips plundered. It's a little special, as it's a revision of the C64 that I haven't encountered before, so I think it's worth the effort. And I do believe I have enough spares left to get it running.
If you enjoy this type of content and want to see it keep coming, there are a few free and easy things you can do to help. Like the video by clicking that little thumbs up button. Likes encourage YouTube to offer this video to more potential viewers like yourself. That helps the channel reach more people. Drop me a note in the comments section below. Comments show YouTube that viewers like you care enough about this type of content to engage with it on a more personal level. Subscribe to the channel and click on the little bell icon so that you'll be notified when new content becomes available. Finally, share a link to this video with your friends or in your social media groups. That again helps expand the reach of the channel. If you're feeling generous and decide you want to support the channel financially, there are a few ways you can do that too. You can become a member of yet another Retro channel by clicking on the join button below. There are also Patreon and Ko-Fi links in the description below the video. I do appreciate all your support in whatever form it takes. Thank you. And now back to the video. Okay, so it's been a day and I've been doing a little research because this is machine number 2. And if you look closely, you'll see that it is not the same as most of the boards we normally work on, and that's because this is actually an early revision board. This is a 326298 revision A, and these would have been found in either the early silver label C64s or the very earliest of the rainbow labels. Now, I've been led to believe that a way to identify that is with the color of the cartridge port, which as you can see is green here, and the color of the power switch, which is red. Unfortunately, what I was what I'm led to believe, and a lot of this information is coming from Aphex Teknol's YouTube channel and from some other information I got from Mark at TheRetroChannel. So what Aphex Teknol said in his video was that the green cartridge connector should be paired with a green power switch, and that would indicate a board that came from one of the silver labels. And that if the power switch is red and the cartridge port is, I don't remember if it was red or black, but that would indicate a board that came from one of the later rainbow label C64s. Now, the case on this one is the rainbow label. However, the serial number is not low. So what I'm guessing is that someone moved their early model board into a later model shell. Their shell probably was damaged or dirty or whatever, and they wanted to fix that, so they replaced the early model shell with a later model shell. So this machine is not going to be 100% authentic no matter what I do to it. So I had to do some research into what is going on in here, and you'll see one of the things that concerned me was these mounting points for two ICs that are not populated. I wanted to make sure that that was correct, and it is. Those should be unpopulated. And then I wanted to know more about the board, and I found out some interesting information. Apparently on these boards, Commodore actually made some mistakes during manufacture that aren't reflected in the schematics. The schematics show them correctly, and then when they were manufactured, they were done incorrectly. For instance, R10, which is in here, this is, I believe, a 300 ohm resistor, and it should actually be a 120 ohm resistor, and that affects the video output quality. So we'll need to replace that resistor at some point. These two capacitors, which are part of the SID filter circuits, I believe these are 2200 picofarad, and they should be 470 nanofarads, so those will have to be swapped out. And there is a flaw in the reset circuit, which it looks like Commodore was originally intending to do correctly, and they, for some reason, decided to change it at build time. There should be a resistor here, but what they did was they left that resistor out, and they put this bodge wire in. And what that does is it affects how external peripherals through the cartridge port or any other port can or cannot reset the computer. And as a result, things like the Easy Flash cartridge, like the Kung Fu Flash cartridge, they don't work correctly with the board in this configuration. So we have a correction to make down here. There are a couple of other corrections we could make. This board has the early 5-pin AV output. As a result, it only has on it audio in, ground, composite out, luminance out, and audio in. It doesn't have chrominance out on it, so you can't use this with either the Commodore video that works with some of the CRT monitors Commodore put out, or with S-Video. And we could correct that by making a couple of little changes. R5, I think it is, right above R10 would need to be swapped out to correct the luminance voltage level on the luminance signal. And we would need to make one more correction to remove this capacitor, to then solder a connection. We'd do it on the back from the right side of this little ceramic over to the left side of where this capacitor is taken out, and add a resistor in there to correct for the chrominance value voltage, and then that would put the luminance on the pin that has the audio input on the AV connector. I'm probably not going to do that because I'm probably never going to use this machine with S-Video. So we'll make the other corrections, but first we have to get this board working. Now, to do that, we're going to first want to check the power rail. And if you'll notice, there's one obvious problem already, and that is there's no fuse. So we're going to actually leave that out at the moment. I have the fuse right here. And we're going to test the switch, test the power connector, and make sure that we're getting good power coming in. And we'll check the voltages across the board and make sure that everything's safe before we start populating any chips. So, first thing I'm going to do is check the power switch itself and see if we're getting any out of whack resistances on the power switch. So the power switch is switched on, which means the center pin and the pin closest to the body of the switch should be connected to each other on each side. So on the 5-volt side, I'm seeing 0 ohms, so that looks good. On the 9-volt side, I'm seeing, well, it's varying, and it seems to be between, yeah, there we go, 0 ohms. So I think our switch is probably okay. Just to be on the safe side, I'm going to go ahead and deoxit both the switch and the power connector. This is a very old machine, and there could easily be some corrosion in there. So for the power connector, we're just going to plug and unplug after we've sprayed the deoxit in, and that should clean the contacts inside. And the switch, I have to try the back. Hard to get the deoxit into the switch without opening the switch up, but we'll give it a shot. Okay. Now turn on my bench power supply, and I should be getting 5 volts on this side of the switch. I'll change into voltage mode. DC voltage. I should be getting 5 volts on this side of the switch. 4.84, 4.8, 4.9. That's pretty good. It's pretty close to what the power supply is providing. This is the 12-volt regulator on this machine. So I should be getting 12 volts here. And I'm getting 11.6364, so that's probably close enough. The 5-volt regulator is in an annoying position. So 5.02 volts, so that's good. And we'll check at the user port and see what we're getting. The DC 4.98, that's good. And AC on the user port is, doesn't matter which direction I put the probes, but we'll try to do it right. We have 10.49 volts on the user port AC. Okay, so our voltages are good, which means that now we can begin populating this board. We're going to be using known good spares, but just to be on the safe side, we're going to try it with the diagnostic cartridge, because we may have problems with the RAM or the logic. So we will start with dead test. As we always have said, the dead test needs 3 chips to run. It needs a VIC-II. And because these are so old and have been sitting empty for so long, I am going to deoxit those sockets. Mess can all be cleaned up later when I give the board a good wash. But for now, that should do. So we have a known working VIC-II. This is an R8. We also need a PLA. Now, as you'll notice, one of the other differences on this board is positioning of the ICs. All we need to do is make sure we're looking at U17, and that's going to be the PLA. So U17 is here. Fit pretty loosely, so I'm not sure we're going to be making good contact there. And we'll need a CPU. Okay, now hook up our video. And let's see if we get anything. Patience, there it goes. Okay, so now you see one of the problems with this board, with the manufacturing of it, is poor video quality. And there's two things we can do. We can adjust some little adjustable caps in the RF modulator, but that probably isn't going to do anything because all the amplification on this board is done down here and not in the RF modulator. So what we need to do to fix that is replace that R10 that I mentioned earlier, and that is a 300 ohm resistor in the board right now, but it needs to be swapped out for a 120. So let's take care of that and see if that improves the video quality. Okay, let's see what that does for our video quality. Much better. All right, we'll let this go through and make sure dead test passes. Okay, so it's passing dead test. Let's see if we can get it to boot to basic. So we will need a character ROM, a kernel ROM, basic ROM, the original basic ROM that was in here, and a couple of CIAs. We do not at the moment need the SID. I'll leave that out for now, but let's see if we get a boot. And indeed we do. And we get a flashing cursor and 38911 basic bytes free. So looks like we're doing well there. Next step, diagnostics. Let's see what we get without the harness. Timers are matching, that's good. Okay, those bads and opens are expected without the harness. So next step, actually let's try the harness before we try the SID. All right, with the full diagnostic harness installed, all right, that's everything but the SID now. And you see the control port and 6581 both show bad. That's because there is no SID. So, pull out our friendly neighborhood ARM SID. And pop this into the board. Now, there should be a slight, and you won't notice it in the diagnostics, but if I try to run Donkey Kong Arcade, there will probably be a slight problem with it because these caps still need changed out. But let's give it a shot with the diagnostics and see if we get a full pass this time and if we get any sound. There you go. A fully functional early 326298 Rev A C64 motherboard. So all that we have left to do is a few modifications. We've already taken care of the video circuit. We need to replace these two capacitors for the arms or for the SID. We need to make the reset circuit mod because at this point we can't run Donkey Kong Arcade with the Easy Flash because this machine won't work with the Easy Flash. So capacitors and reset circuit still need to be done. Okay, so to make these two modifications, the reset circuit and the filter caps, the first thing we're going to do is clear out the holes for resistor 36 here on the board. It looks like Commodore did plan on making this circuit correctly, but they just didn't end up doing it that way. So I'm going to first clear off some of this solder from the pad where the bottom RF shield gets soldered on, and then get the solder out of the two holes. That was easy with the wick. And then we take a 1000 ohm resistor, 1K, pop that into the board. And solder it in. And the second part of the job is to clip pin 9 on the 556 timer, which is right here. 1, 2, 3, 4, 5, 6, 7, yeah. As I thought, pin 9 is this pin right here. Now we've got a bronze wire going around here, and that needs to stay. So you need to clip the pin close to the body of the chip. That should do it. Make sure there's no continuity between the board and the chip, and there isn't. We're good. So that should be the reset fix. And now we just need to clear these two capacitors. And 2. And yeah, the holes are already clear. So I should be able to install my two new 470 picofarads. These are going to need a little bending to work. That should be our two mods completed. Now, the arm SID back. Took it out just to be on the extra cautious side. And now we should be able to hook up and use the Easy Flash 3 cartridge. Okay. Power supply, there we go. Now, we should get the Easy Flash cartridge. Come on. There we go. Still crap video. But, hey. Games 1. It's working. And Donkey Kong Arcade. And that does it. We're done with this machine. It is as working as it's going to get. Now, there is another mod that I could make here. The voltage regulator, the 7805 on this machine, just has a tiny little heat sink, and it gets very, very, very hot. And I've seen it recommended by Mark from TheRetroChannel and others that you go ahead and pull that regulator out of the board, drill a small hole for the mounting screw in the RF shield for the cartridge connector, mount the regulator to that, and then run wires back to the board. I may do that at some point in the future. I'm not going to do it tonight because that involves drilling, and I don't feel like drilling a hole right now. So we're going to call this complete. And that truly does finish off the 2024 Commodore 64 Repairathon here on yet another retro channel. Now, if you'll recall, there is one more machine that we haven't touched, and that was, I think, machine 5 or 6. I forget the number right now. Not important. But that was the machine that seemed to have had the massive power surge. That machine I'm going to hold off on, and actually I'm going to record a special video with that one for my channel supporters, both YouTube channel members and Patreon members. I'll be recording that sometime in the near future when I have the time. But at the moment, we have 9 of the 10 boards working and a plan for number 10. And I'm glad that you stuck with me through all this. I appreciate you watching. I appreciate all the comments. As you heard in this video, I did take some of your comments to heart and tried to implement what you told me. I really do appreciate that. It's very helpful. And yeah, I think that's everything. Only left for me to wish you health and safety and promise you that I'll see you in the next one. Bye.